Hi, I'm Vicki Carter. I'm an educator from South Carolina. Today I would like to share with you a TI-inspired activity that utilizes TI-Nspire technology that demonstrates piecewise linear integrals. In this activity, students will explore the area under a piecewise linear function. I really like to use this activity in my classroom and have students come to the board and work together to explore this document. This particular activity works best on the teacher software as a demonstration as opposed to the students using their handhelds in the classroom. The reason for this is that the activity runs a little bit slow on the student handheld, but it is a wonderful activity to demonstrate to the class and actually have students come to the smartboard or interactive board that you may have and manipulate the graph. I'll demonstrate this to you now. So we have our introduction page, which is going to basically tell us that we are going to be able to change the graph of f of x by dragging vertices. We are going to be able to change the graph of f of x by dragging vertices on the graph on the next page. The students will see a piecewise linear function. We also have some slider bars here that will allow us to change the values of a and x. And we see a demonstration of the area under the curve as being shaded here, and below we see the evaluation of the definite integral that corresponds to this graph. Notice that a is our left endpoint, x is our right endpoint, and so we are evaluating the value of an integral from a to x. And right now it's 0. This is a wonderful demonstration of a way to ask the students, why is it 0? What are the characteristics of this graph that we see right now that would make the value of this definite integral 0? I love to ask the students to come to the board and demonstrate another value for a and x that may give them 0. I like to have the students in groups as we work with this activity and actually bring the students up in pairs so that they can communicate about the document and make decisions about how they may change the value of a and x. For instance, they may change the value of a by sliding the open circle, or they may change the value of a by clicking on the clicker that we have here on the left. So students will have the opportunity to manipulate the area under the curve and see how it affects the value of the definite integral. Not only do they have the opportunity to change a and x, but they may also grab those vertices and change the actual piecewise function. This is a very powerful demonstration of how a piecewise function and how the areas of geometric figures such as rectangles, triangles, and trapezoids can be used to compute the value of a definite integral. It doesn't take students very long to ask a what-if question, such as, what if the value of x is less than the value of a? So I ask a student to demonstrate this. And then you have the opportunity to ask some questions about, well, why is the value of the definite integral negative when we actually have an area that is above the x-axis? And it leads to some wonderful communication among the students who are working in groups in order to talk about what has actually happened. There's a second part of this activity. The students are going to be given the graph of an integral or an antiderivative as well as a piecewise linear function f, and we're going to have a split screen here. Notice that you now have a wonderful connection between the area under the curve and what is actually happening with the function. Students may again click the A or the X clickers here to change the values of a and x. They may also look at how the graph in the top and the area under the curve is connected to the graph at the bottom. So as a decreases, what is happening to the value of that function? And as a increases, what is happening to that function? This is a wonderful aha moment in the classroom because students will now realize that changing the value of a is actually a vertical translation of the graph of the function at the bottom. I hope you enjoyed the demonstration of this activity using TI-Nspire technology. You can find this activity on mathinspired.com. Thank you.